Welcome to this session on image enhancement. This is the third session on image enhancement. So in first two sessions, we have discussed image enhancement techniques where we have performed point processing on the pixels. Now in the next part, it is the neighborhood processing techniques where we will consider, if suppose this is a pixel we have, then we'll consider the neighbor pixels also, or the gray value of neighbor pixels also, for creating or for calculating the value of pixel. So that is called as neighborhood processing technique. Now we have seen what is my neighborhood processing. So here normally 3 by 3, 5 by 5 spatial masks are used. So mask means such type of mask you will have, means 3 by 3 mask like this. So it has some weights W1, W2, W3, W4, W5, W6, W7, W8, W9. So such type of weights are available, and you are applying that weights or filters over the image to get the proper output. So we have this particular, if suppose this is the part of image, it is not a complete image, this is some part of image, and if I want to modify Z5 with the help of mask, this is a 3 by 3 mask. So how I will apply the mask, I will locate this W5 here, and I will overlap this mask completely so that W1 will be multiplied with Z1 plus W2 with Z2 plus W3 with Z3, W4 with Z4, W5 with Z5, W6 with Z6, W7 with W7, Z7, W8, Z8, W8, 9, this one. So that whatever value you are getting after calculation, it will replace the Z5. It will replace the Z5. So that is called as neighborhood processing. And now in next iteration, this mask will, W5 will locate here, and the mask will be something like this. And again, you have to perform it and you have to identify it. So this is called as neighborhood processing. The neighborhood processing, it is divided into two parts, that is smoothing filters. So they are used to remove unwanted noise from the image, and it preserves all details. It is not removing anything from the image, it is retaining the details. The example is low pass filter is the example. Then sharpening is another type of neighborhood processing. So sharpening is nothing but it is used to highlight fine details from the image. You will highlight the some part or fine details from the image. Normally whenever you are considering any image, for example I have this image, consider this is image where this is black part and this is white part. Then from this image, as we are considering this image as a spatial domain representation, spatial domain, so in that case the low pass region is nothing but the region where frequency change is slow. So here it is a low pass region. Okay, low pass region. Here also it is a low pass region or low pass frequency region. And what is the high frequency region from this image? The age between them. This is high means the drastic change in the intensity, black to white. So this part is high frequency region in spatial domain. So in case of smoothing the filters or smoothing filters, we are blurring those particular lines. We are blurring those lines. And in case of sharpening, we are removing low pass region and we are highlighting the difference. So that is called as smoothing filters and sharpening filters. Now first we'll begin with the smoothing filters. First is low pass filtering. It is also called as averaging filter. This low pass filter is also called as averaging filter. Now see, in low pass frequency, as I have told, if you consider the image and image contains black and white part, where the frequency means if there is no drastic change in the intensity, that region will be low pass region or low frequency region. It is also low frequency region. And here at the edge, you are getting drastic change from white to black and black to white. So this is high region, high frequency region. So in frequency domain representation, low pass filter will be represented like this, where low frequencies will be passed and high frequencies will be attenuated. And in case of spatial domain, it is represented like this. It is represented like this one. So it is nothing but a spatial domain representation for low pass filter. So in low pass filtering, it removes the high frequency and keeps low frequency as it is. If suppose it is an example, if suppose this is an image taken as an input, and if you apply the means filter, low pass filter, so what will be the output? So this is the output. There is no drastic change in the output, but you will see, I will zoom those images. Here you can see the edges. This is the edge. Okay, this is the edge, and this is this is low pass region, this is low pass region, this is low pass region, but edge means the edge is high pass region. Now here you can see after applying low pass filter, it blurs somewhat. The edges are blurred due to low pass region or low frequency or low pass frequency filtering or low pass filtering. So that is done by using low pass filtering. Okay. Now how to perform low pass filter or low pass filtering? For example, in low pass filter, the mask 3 by 3 mask, I will write 3 by 3 mask. The mask is, for low pass filter, the mask is 1 1 1 1 1 1 1 1 1 1 by 9. So this is the mask for low pass filter, 3 by 3 mask. This is the 3 by 3 mask. You can use 5 by 5, you will have 7 by 7 mask. So this is the 3 by 3 mask. Now see, I will show you one example how that low pass filter works and how to perform the operation on it. For example, I am taking an image. Okay, I am taking an image. I'm taking image, and here is the 10 10 10 10 10 10 10 10 10 and 10, and suppose here it is 100 100 100 100 100 100. So 100 100 100 100 100, correct? So here you can see this is low frequency region, this is low, and this is high frequency region, correct? Now apply the mask. How to apply the mask? So that is important thing. I will start applying from here. Okay, I will start applying from this upper left corner. So that this is the center, it must be located here, and this mask will be like this. Okay, mask will be like this. Mask will be like this. Here also, if you want to perform the operation, what you have to do, you have to take, this is 10, this is 10, this is 100, means extend this, this is 100, this is 10 10 10 10 10, and this is 10. Okay, so you have to consider this row. Now what is the answer? 10 plus 10 plus 10, 30, 60, 90. 90 divided by 9 means 10. So what is the output after performing the first operation, first filtering? First output is 10. Now next, once this is over, okay, so once again, I will show you 3 by 3 mask. So it is normally the mask like this. It is 1 1 1 1 1 1 1 1 1 and 1 multiplied by 1 by 9. And we have taken the image. Suppose 4 by 4 image I am taking, and those are 10 10 10 10 10 10 10 10 100 100 100 100 100 100 100 100. So for calculation purpose, you can consider those rows as replicate. You can replicate it so that it is better to calculate 100 100 100 100 100 10, 10, 10, 10, 10, 10, 10, and 10. Okay. Now put the mask over it. This is a mask. So I want to modify this particular point. So I will put the mask like this. Okay. 3 by 3 mask. Now this is the output image. I will have output image. Now first calculation, total 90 divided by 9 will be 10. Once it is done, what you have to do, you have to shift your mask to next position. You have to shift to next position, so that once you shift it, the mask will be like this. Mask will be applied here. Mask will be applied here. Now perform this 10 into 1, 10, 10, 10, means it is all 1. So you can multiply 1 into 10, 10, plus 10 into 1 plus 10, plus 1 into 10, 10. So total is 90 divided by 9. So it is 10. Now next, this mass will be shifted towards right. So it will be shifted the third position. So again, it will be shifted to next location. So it will be shifted here. Okay. So mass will be like this. So again it is 10. Then next it is 10 over. Now after this, the mass and this one will come to next line. Now it will come to this line, means next row. So mass will be like this. So what is the addition? 10, 10, 10, 30, 30, 60, 60 plus 300, 360, correct? 360 divided by 9, 40. So this will become 40. Similarly, this mass now next shifted to this location. Mass will be shifted here. This is next location of the mass, and mass will overlap with those 9 points. So what will be the answer at that location? 60, 360 divided by 9. So it will be 40. So answer is 40 for this. 40. Then here it will move towards next position, this position. So that those 3, 6 and 360, again 40. Then this mass will be shifted to that location. So it is again 40. Okay. After performing it, mass will come to next location, and that is nothing but next row. Next row. It will come to next row. Now mass will be located at this location, so that it is nothing but the position of the mass. Now it will multiply 10 plus 10, 30, 30 plus 100, 300, 600, 630, 600. So 630 divided by 9, 70. So answer is 70. So answer is 70. Then again this mass will be shifted next location. Again the same 10, 10, 10, 30, and it is 630, means it will be 70. Then again it will be shifted. Again it will be 70. It will be 70. Now next position is this one, this position. So what will be the answer? 900 by 9. So 100. Then 100. Then 100. Now 100. Now see, the first row it is as it is, last row is as it is. But wherever there is a drastic change in the intensity, it was average. It was 40 and 70. It is average. So it is blurred. It is blurred. So this is nothing but how you can apply the low pass filter using 3 by 3 mask. So mask, you must remember, the mask is all ones, and it is multiplied by 1 by 9. Means what is the W1? 1 by 9, 1 by 9, 1 by 9, 1 by 9. So this is the mask for low pass filter. And you have applied the low pass filter where the region, here is the region where intensities are drastically changing. So it is nothing but called as high pass region. So it is average out. So that because of that it becomes 40 and 70, 40, 70, 40, 70, 40, 70. So this is nothing but how you can apply the low pass filter mask. Now next, sharpening filters. Now what is the use of sharpening filters? Sharpening filters, the filters, they are highlighting the important part, or you can say high frequency region. Now here you can see this is the image. As I have told, this is the low frequency region, this is low frequency region, this is low frequency region, low frequency, low frequency, low frequency, and wherever there is a drastic change, it is high frequency region. So in high pass filter, whenever you will use the this is the frequency domain representation, this is frequency domain representation. Similarly, you can have this frequency domain representation, it is spatial domain representation, spatial domain. So you can have the filter like this one. Okay, so if you apply high pass filter, then at that time what happens? So this is the output, means what, it will remove the low frequency, it is removed, it is removed, it is removed. Only high pass means the drastic change or edges are shown, edges are shown, edges are shown. So here you can find this is the edge, this is called as high pass region. So what is the use of high pass filtering? It will highlight the edges, highlight the important thing. So this is nothing but edges are highlighted by using high pass filter. Now, what is the high pass filtering, or what is the mask that can be used for high pass filter? Okay, so the mask for high pass filter mask 3x3 mask will take 3x3. So this mask is 1/9. It is -1, -1, -1, -1, 8, -1, -1, -1, -1. So this is the mask for high pass filter. This is mask for high pass filter. It is 1/9. You can have 5x5 mask, no problem. You will have 7x7 mask. Now we'll apply the mask over the last problem. Okay, how to apply it? We will apply on the same problem whatever we have discussed in the low pass filter. So it is 10, 10, 10, 10, 10, 10, 10, 10, and next was 100, 100. It was 100, 100, 100, 100. It was 100, 100, 100, 100, then 100, 100, 100, 100. Okay. Now apply it. We know the procedure how to apply it. So we will make this as a 10, 10, 100, 100 for our calculation purpose. We are adding one row, one column like this. So for that, otherwise you can also consider 0, no issue. 10, 10, 10, 10, 10, 10, 10, and 10. This is the first value. So I will have the mask like this. So what is the answer for this one? This is minus, multiply means -10, -10, -10, -30. This is -10. Okay, -10. This is 8 into 80 plus 80. 80 -10 means -40. So see here 30, 40, 40, 80 get cancelled. So answer for this first value will be 0. Next, if you apply to next one, again this will become 0, 0, 0. Okay. Now we'll move towards next row. We'll move towards next row. So this is the next row, and mass will be like this. Mass will be like this. So try to find out the answer. So it is all are minus. So means -30, -40, -50, -50, minus this is those are 300, -300, and plus 80. Okay, plus 80. So answer is 270, -270. But there is no any what you can say. There is no any value which will have value as a negative. Means grayscale is never negative. Never negative. So this is equal to 0. So it will be 0. So you can have this row also 0. Now next, we will move towards next one. Now we can apply mask at this location. So that mask will be like this. Now perform the operation. 1, 2, 3, 30 minus 30. Then 1, 2, 3, 4, 5 minus 500. Okay. And this is 8 into 100. So plus 800 divided by 9. So it is equal to 530 means 500, 300 means 270 divided by 9. So answer is 270 divided by 9, 30. So answer is 30. Then again, if you perform the same, you will get 30, 30, 30, 30. Okay. And next one at this location, at this location. So 100, 100 are there. So it is nothing but 1, 2, 3, 4, 5, 6, 7, 8. Those are minus 800. And this is plus 800. So answer is equal to 0. So it is 0, 0, 0, 0. So means only the drastic change age is defined, or age is identified by using high pass filter mask. So this is nothing but how you can filter the high pass region and you can remove the low pass region. Understood? So this is nothing but how you can apply the filter mask. Now next mask is median filter mask. So what do you mean by median filter mask? So in median filter mask, if you want to modify the pixel value, the value of the pixel is replaced with the median of pixels values in the window around it. So what do you mean by median? If suppose median, I want to find median of 4, 3, 1, 2, 5. Okay, 5, there are 5 values and I want to find median. How to find the median? Arrange in ascending order. So 1, 2, 3, 4, 5. Okay, and select middle value, that is nothing but 3. So this is a median. This is median. So here in case of image processing, you have to calculate the pixel value. You have to replace the pixel value by calculating the medians of the pixel around the particular pixel, and you have to replace it. So how? I will show you. Now median filter, it is used to remove paper and salt noise from the image. Now what do you mean by paper and salt noise? Paper and salt noise means white and black dots in the image. So how? I will show you. Suppose this is the image and this image having some dots, white dots as a salt and black dots as a paper. So those are the paper and salt noise, white dots as a salt and black as a paper. So this particular noise can be removed by using median filter. And if you apply the median filter, you will get the output like this. You will get the output, proper output. So this is nothing but the use of median filter. How? I will show you how this will remove. I will take an example of it. Okay. Suppose there is an image. This is an image, suppose 5x4 image, and this image contains 1, 2, 1, 2, 3, 1. As a 0 means black part. Okay, 1, 2, 1, 2, and 7 means white spot. 2, 3, 4, 1, 2, 3, 4, 0. And those 0 means black spot and 7 means white part, because it is nothing but 3 bit per pixel representation. 3 bits per pixel representation. Now my aim is to apply the median filter. Apply median filter. Now what is the median filter? It is the empty mask you can consider. It is empty mask, and whichever pixels or whichever values you are getting, arrange in ascending order and select middle value. Now I will apply this. I will select those also 1, 1, 2, 1, 2, 2, 2, 3, 4, 0, 0, 0, 2, 7, 1, 2, 2, 2, 1, 2, 1, 1. Okay, for application purpose, select this. Now start from this one. Apply this mask. This is a mask. Okay, this is a mask. Now what are the numbers? Numbers you can write for ascending order: 1, 1, 1, 1, 1, 1. Okay, there are how many ones are there? 1, 2, 3, 4, 5, 6. And there is one more as a 0, and then 2 and 2. So which is the middle value? Was 0, 1, 2, 4, 5. This is the middle value. Okay, this is the middle value. So you have to replace this middle value to the value of the pixel. So the value is 1. Now shift the mask at this location. So again, at that location, what are the values? 0, 1, 1, 1, 1. How many ones are there? This mask will be like this. This mask will be like this, in this way. So that the values are 1, 2, 3, 4 ones are there, 5 ones are there, 1, 0, then 2, 2, and then 3, which is middle value 0, 1, 2, 3, 4. So this is 1 as a 1, 2, 3, 4, 5, 1. So answer is 1. Then again it will move towards next one, this one. So if you arrange that, go for that, arrange it 0, 1, 1, 1. Then there are 2 3s, 2, 2, 2, and then 3, which is middle value 2. So answer is 2. Now instead of that, what we will do, I will show you how that 0 means black spot is removed. Okay, black spot is removed. Suppose this is a 0 and which is a dark part, so that you will apply the median filter like this, median filter. Now that numbers you can arrange in increasing order. So 0, then there are 1, 1, 1, 1, and then there are 2 3s and 1 3. So which is the median value? 1. So that this 0th location will be replaced by 1. Again, if you applied the 7, okay, it means this is the white spot. So how you can increase 1, 1, 2, 2, 2. So you will get 2 as a value, 2 value. So that wherever you are having the spikes, those actually this is 8-bit representation of the image, where white spot is 255 and 0 is 0 and other is gradually changing. So you are removing it. So I will show you practically also how this median filter is applied. So this is nothing but how median filter will be applied. Now next topic of discussion, that is zooming. How to zoom the image, zooming, how the zooming of the image is done. So zooming means enlarging the image or showing enlargement of the image. Now zooming of the image, it is performed by two methods. One is replication. There are two methods, replication, and second is linear interpolation. So by using two methods, the zooming is performed. Now how to perform the zooming? First method, we'll have the replication. Now see here, if suppose this is an image, of 1 2 1 3, okay, 1 2 1 3 or 4 3, and you want to zoom it out, then how you can zoom this? And you can use replication for it. How to replicate it? First of all, repeat each pixel along the scan line. So you repeat it along the scan line, then what will happen? So this 1 is repeated, 1 1, then 2 is repeated, 2 2, then 4 is repeated, 4 4, 3 is repeated, 3 3. Okay, then again replicate each scan line, so that it will become 1 1 2 2. The same line will be repeated as 1 1 2 2, then 4 4 3 3, then same line will be repeated as a 4 4 3 3. So this is nothing but the technique called as replication for zooming the object or zooming the image. So that finally, what is the image we have received? Earlier it was 2 by 2. After zooming, it becomes 4 by 4. And the numbers are just replicated initially by along scan line, and then each scan line is repeated. So it is 1 1 2 2, 1 1 2 2, 4 4 3 3, 4 4 3 3. Okay, so this is the replication or the zooming, first technique of zooming, that is replication. Now next technique next technique of zooming, that is interpolation. Interpolation. Now how to perform the interpolation? Now we'll take the same example for it. It is 1 2 4 3. Okay, now what you have to do, initially make it double. It is 2 by 2, make it 4 by 4. How you can make it? 1, then add 0, then 2 0, then it is 0 0 0 0, then it is 4 0 3 0, and then 0 0 0 0. And in between values, those zeros are related as you have to add those two numbers and then divide by 2. That is nothing but this point. So how you will get this? So 1 plus 2 3, 3 divided by 2, it is 1 point, means 1, 1.5. 2 plus some value will be there, or you will have 0. Suppose it is 2, then 1. Then next 4 plus 3 7, 4 3.5, 3 3 means 1.5. And similarly you can have 4 plus 4 5 divided by this one is 5 2.5, 5 2.5, 2.5, and this one 2 2.5 means 1.25. So you can average it. 1.5 will become as a 1, or it may be you can take it as a 2. So 1.25 will be equal to 1. So likewise you can interpolate, or you can increase the size of image. You can increase the size of image. So this is the second technique for zooming the images, that is called as interpolation. Okay, now we'll perform the practicals. I will share the link soon. Okay, from here you can leave.